Hello. I'm going to do a walkthrough of Coingame. So the game goes as follows. You have some list of numbers. So let's say like 1, 5, 10, 25. And there are two players. So player 1 goes first, and each player can basically choose to remove either one or two numbers from the end of this list. So player 1 could potentially remove 25 and 35, and their score would then become the sum of those numbers, 35. Then player 2 can choose to remove, say, 5 and 1, and their score would be 6. But this list could go on like longer, so maybe I had a 3 there, and player 1 could then remove that 3, and their score would be 38. Yeah, that's basically how this game works. What we're trying to do is figure out the maximum score that player 1 can get if player 2 plays optimally. And player 2 playing optimally means they minimize player 1's score, which is actually equivalent to maximizing their own score. But we don't really care about that too much. We want to minimize the opponent's score, which is player 1's. So how the function is structured is basically there's this player Boolean variable that's passed in, and if player is true, then we're at player 1. And if player is false, then we're at player 2. Alright? If the setup isn't clear, just pause and read over it once, and I'm going to start working through it. Okay, so there seem to be three main cases here, and the first two are just one-line return statements, so these are probably going to be like some sort of base cases. And they have this condition and player and not player. So this implies that you're at player 1 and you're at player 2, because if your player variable is false, then you're player 2, and so not player would be true. Okay, so we're going to try to figure out what these base cases are first. So let's do the examples in the doc tests. There's definitely problems where you can figure out the recursive case first, but this is not one of them. I think the base cases are easier to figure out to reason through the game. So the first base case is if you just have the element 1 and you're at player 1. So in this case, player 1 only has one choice, which is to take this 1. So this would just give us a score of 1. Okay, so similar to that, another option where player 1 has no choice is if there's two elements. Because the best thing for player 1 to do here is choose both of them. So this is another base case. So to summarize, the two base cases we came up with were when there's two elements or there's one element. So we can say that if the length of the list is less than or equal to 2, then we want to return the score. So in this case, the score is 1. In this case, the score is 5 plus 1, which is 6. So in other words, we're summing all the elements in this list. So we can use the sum function. Okay. And so let's try the same thing, but for player 2. Let's say you have both of these elements, 1, 5, and then 5 with player 2. So what's player 2 going to do to be optimal? Again, player 2 wants to minimize player 1's score, so player 2 is going to want to give them nothing to pick. And so player 2 is going to pick both of them, and their score is going to be 6, and their score is going to be 5. However, what our function is returning, Coingame, is the score of player 1. So highest score that the first player can get. And so we don't want to just return the total score that gets accumulated. We want to return what I just described. And so in this case, if player 2 takes both of these, you have an empty list. So therefore, you can say that player 1 will now score 0, because player 1 has nothing to choose from. Okay, let's do the bulk of the logic here. So first, they have this statement if player. So if you are at player 1, then like what choices do you have? So the game describes that we can either pick the last or the second to last element, or last or both the last and the second to last. And so they seem to have made some like convenient variables for us. So let's assume that these names are good, and just assign this to the last element. And one way of saying that would just be list of -1. You could also say list of len of list -1. And this would just be list of -2. Now we know these exist because our base case is checked for them. Okay, and now the last thing we want to do is we want to somehow combine these choices. So let's try to figure out what I can do here. So if I have, say, like this list, 1, 5, 25, if I choose just 25, then the remaining list becomes 1, 5. If I choose both 5 and 25, the remaining list just becomes 1. And so what I'm essentially doing is playing one move of the game. So either I choose one thing or I choose both of them. And using those, my score gets accumulated. So now that player 1 has played a move, what we can do is call a Coingame, but now pass in our player as player 2. So now then it'll be player 2's turn, and we'll handle in this else case. So either your score can be 25, or your score can be 30. And that's not your entire score. Your score is this score plus whatever score you accumulate in the rest of the game. So these are probably just going to be calls to Coingame. So we can call Coingame on this list, and false, which means player 2, and the same thing for the other side. And what do we want to do with these? We want to figure out the maximum possible score we can get. So we can take the max of these two outcomes. So more specifically, outcome 1 is described as us getting the score 25 plus Coingame on the rest of the list, where we pass in player 2, and the other one is pretty similar. I might as well just write it. It's 25 plus 5 plus Coingame of 1. Okay, so let's try to come up with the first outcome. So in the first outcome, we basically took the last element and added it to Coingame of the list sliced with the last element removed. So another way of writing that is just using :-1, and you can also do the same :len of list -1. And we're passing in false because we're switching players. Okay, and the other one we can do is second to last, that's our 5, plus last, plus Coingame. And now we're going to cut the list by 2 elements, so I can just make the -1 into a -2. Okay, so that's going to be our case with our player 1. Now what do you want to do with player 2? So what did we say player 2's goal was? Player 2's goal was to minimize player 1's score. And what does our Coingame function return? It returns the player 1's score. So we can essentially call this Coingame function and take the minimum over 2 different calls. So the first call, now let's say we're starting with the same scenario, but this is player 2. So the first call would be this list becomes 1, 5, and we just choose one element. And otherwise it could become 1, and we have chosen both the elements. So now notice that we're not keeping track of player 2's score, so we don't need to add anything. We simply need to figure out which one of these minimizes the score, and choose that one as our move. So in this case, you'll want to choose the one on the right. And the reason why is because on the left, player 1 could just choose both of these and get a score of 6. And here, player 1 can only choose one of them and get a score of 1. So you take the minimum of 1 and 6, and output that as player 1's final score, or player 1's score given this input. So all we can do is call Coingame of removing one element and true, and Coingame of removing two elements and true. Alright, yeah, that's Coingame. I know it was a pretty intimidating question. I hope that cleared some doubts. You guys feel more confident for the midterm? Yeah, thanks.